Now we're going to do example 4.
Now for example 4, you're going to find f if f to the prime 2, I don't know how to say that, equals 12x squared plus 6x minus 4, where f of 0 equals 4 and f of 1 equals 1. So we're going to take this like one step at a time, and we're going to take the first antiderivative, which will be f prime x equals, we'll write it out step by step, so it's easy, x 2 plus 1 over 2 plus 1 plus 6 times x 1 plus 1 over 1 plus 1 minus 4x, since when you take a derivative, the variable goes away, plus c. Don't forget the c. Now to simplify this, we get f of x equals 12x cubed over 3 plus 6x squared over 2 minus 4, let me fix that, minus 4x plus c. We can cancel those, which gives us f prime of x equals 4x cubed plus 3x squared minus 4x. Now, we're going to have to take the antiderivative again. So to mark where we're going to do that, I'm going to write again right here. So then we get f of x equals, I'm going to write it out step by step just so no one gets confused and that it's very clear to understand, plus 3 times x2 plus 1 over 2 plus 1 minus 4x 1 plus 1 over 1 plus 1 plus cx, add the variable, and then we're going to add plus d because that's our new constant. So clean this up, we'll have f of x equals, we'll do 4x to the 4th over 4 plus 3x cubed over 3 minus 4x squared over 2 plus c of x plus d, our new constant. Now we can cancel these, simplify it, another cleanup, which will get x4 plus x cubed minus, that'll be 2x squared plus cx plus d. Now we can find d first because we're going to want to find the constant first. So to find d, we're going to do f of 0 equals 4. Use the first one that we were given. So if we do this, we do f of 0 equals 0 to the 4th plus 0 to the 3rd minus 2, 0 squared plus c times 0 plus d equals 4. When we do that, obviously we get 0, 0, 0, 0, which means d equals 4. Now, we want to find c. And to do this, we'll use the second one that we were given. And if we plug that in, 1 equals 1 to the 4th plus 1 to the 3rd minus 2 times 1 squared plus c times 1 plus 4, since now we have to plug that in. And then we all set it equal to 1. This gives us 1 plus 1 minus 2 plus c plus 4 equals 1. We get c equals -3. And then that means our final equation, sorry, that was like a d. Our final equation is going to be f of x equals x to the fourth plus x to the third minus 2x squared minus 3x plus 4.
So that gives us our final answer. And moving on from that, so if we are given a graph of a function f, it seems reasonable that we should be able to sketch the graph of an antiderivative, capital F. So suppose we are given f of 0 equals 1. This gives us a point at 0, 1, and the derivative f prime of x equals f of x will show us which way we move our pencils in the stages of this derivative. And this is a place to start. In the next example, it will use the principles of this chapter to show how to graph f even when we don't have a formula for f. An example of this would be f of x is determined by experimental data. So for example 5, we're given this graph to the left, and we're going to make a rough draft of its antiderivative. We are also given f of 0 equals 2. And we know that the slope of y equals capital F of x is f of x. And we also have a point at 0, 2. Capital F is initially decreasing because f of x is negative when it's 0 less than x less than 1. I'll give time to write. We can also see from the graph, if we look at these points 1 and 3, that f of 1 is also equal to f of 3, which are both equal to 0, which means that f has horizontal tangent lines when x equals 1 and x equals 3. Okay. Now, for 1 to x to 3, f of x is positive, as we can see on the graph, which means that f is increasing. We also see that f has a local minimum at x equals 1 and a local maximum at x equals 3. For x greater than 3, f of x is negative. So capital F is decreasing. If we were to write an interval, it'd be on 3 to infinity. Since f of x is approaching 0 as x is approaching infinity, the graph of f becomes flatter as x goes to infinity. Also notice that f double prime of x equals f of x. And from this we can see that there's changes from positive to negative at x equals 2 because it goes from increasing to decreasing. And it does this change, I'll get rid of these. It goes from positive to negative at x equals 2, and it goes from negative to positive at x equals 4, which means that there's point of inflections on f, capital F, at x equals 2 and x equals 4. So now we can take these and sketch it. We were first given that we have a point at 0, 2, so we can automatically do that. The next, we know that it's decreasing from 0 to 1 because we got that up here. We also know that there's a minimum at x equals 1 and a point of inflection at 2. So that means we can start going up, but it'll change concavity at 2. We are also told that there is a maximum at 3. Once we have that, then we can see that it Anything greater than 3, it is now decreasing because it was negative on f of x. And then it'll flatten out. So then we get this sketch. And to double check this, we can check the answer, which looks pretty close to what we got.